Welcome to Image Processing with ArcGIS Pro. 12 YouTube videos summarize image processing lab exercises available in a step-by-step lab manual that accompanies this textbook. Download the lab manuals at the site shown and obtain more textbook information at the second site shown publisher's website. Download the lab manual and data used in the lab exercises if you want to use the step-by-step instructions and process the imagery and DEMs while viewing the YouTube videos. The examples used in the videos and lab manual are discussed and shown in the textbook, improving GIS student understanding of essential remote sensing principles and technology while learning how to process and enhance images and DEMs using ArcGIS Pro. The lab manual, a page is shown in the upper right, and 12 YouTube videos are designed for GIS instructors, students, and users who want to do their own processing, enhancement, and information extraction of satellite and airborne images and DEMs using ArcGIS Pro. You can see the 12 exercises, the tutorials listed here. They cover a broad range of image processing tasks, algorithms, and help you find where these tasks are located on the various menus in ArcGIS Pro. The lab exercises require ArcGIS Spatial Analyst extension. Contact Ellis at ellis-geospatial.com for any questions or comments, and visit the publisher's website for more information and resources on the textbook. Lab 10 covers Supervised Classification. We will be generating a land use land cover map. The steps we're going to be going through are listed here. We're going to evaluate the 8 input bands for this classification, decide on the categories of our classification, produce training samples, and that'll take a while so that we can develop a signature file that's then applied so that the maximum likelihood classification program develops this map, LULC map. Then we'll add class names to the attribute table. We'll look at the map a little bit and then fade the map onto a hillshade DEM. And if we have time in this video, also use the field calculator to add area to the attribute table. So we'll bring over this scene of a suburban industrial area in Central California. Go to symbology. I should change that options because band 3 is really Landsat, the red. And so we've got a pretty good looking natural color image here. Brighten up a bit. First thing we want to do is run statistics. Take all the defaults and just run. And it goes ahead and reverses the order of the bands. So let's look at the bands that make up this data set. Notice it says 6 bands, 2 principal components. So if I go to my stretch symbology, this is looking at band 1. Here's band 4, very sensitive to healthy vegetation as the brightest pixels, and very dark in the water. But you can see when we go out to band 6, which is one of the shortwave infrareds, it still looks very similar to the others, but we go to 7 and 8. This is PC3. From the original 6-band Landsat, and it's really unique data. That's why I put it in this classification. And then 8 is also quite unique. So they bring different spectral characteristics to the classification, and I think it will improve the accuracy of our mapping. In the textbook, it discusses the 6 Landsat bands, the 2 PCs, and then shows this table, a correlation matrix table. And notice if it's close to 1, it's highly correlated, so blue is highly correlated with green. But when you get to the, say, band 5 and you look at what happened PC3, these very low correlations, it brings in really different kind of spectral information. That's why we want to use it. So when you're evaluating this area, it's really good to have different color composites of the multispectral imagery. Here we're looking at the natural color. So we have a wetlands up here, some water there, golf course there, suburbia, and look at it in enhanced color, and you see different features are popped out. The industrial zone really pops out. The texture inside of the wetlands is more apparent. So also load up a color infrared and look at those before you start to classify. Now, one thing we have to do is we have to come up with categories for our classification map. And so just as a placeholder in the lab manual, picked up these. Number 1 is river water, 2 will be ponded water, irrigated grass, dry grass, wetlands, suburbs, industry, and trees. So we're going to work with 8 categories, and we have to develop training areas for each of these categories. These are 8 categories. In the textbook, 17 training sites were developed. So you can really get a lot more information into your map with more training sites. So now we actually want to develop the training samples, and we use the training samples manager, which pops up here on the right. And the default is the land use classification that's used by the USGS, which is really good, but it's not appropriate for what we want to do. So we want to develop our own classification scheme and create a new schema. And this is how you do it. You just click this icon here, the new schema comes up. You can edit it, and we'll call it the Lab 10 land cover, and we'll leave the rest of it blank. Now we want to add our classes, our 8 classes, to this schema. And so you click on the green plus sign, and the first one will be river water, and we'll give it a value of 1 and color it dark blue and say OK. And then you go back and you highlight this, because if you highlight this one, it'll be a subclass. So you highlight the top one, you do it again, and the second one is ponded water, and its value 2. And it's, let's say it's not such a bright color. And then we sequentially go through and we'll add those other 6 classes, which I'll do next. And I'll add the last one. You got to remember to touch this, so they're not subclasses. Trees, number 8. Give it a real nice dark green. So this is our schema, and to save it, save as, just the location. So I'm just going to put it in the Lab 10 output folder. And now it's saved. Now you can see across the top it says select a class to start drawing shapes. So I'm going to just do river water. I'll zoom in, and you pick one of these tools. I'm going to do the polygon, and you click around, and when you're all done, double click, and that's your first training site. We'll do one over here. Notice we have these tools. The training manager allows you to do very many things. Collapse classes. So if I picked both of these, I can collapse them into one. I can split them. I can change the colors. Do all sorts of things with this tool. It's a very powerful tool. And to move around, you have to touch that C key. And we'll notice what happens if I pick a different color composite. You can see that I'm seeing more information here. I haven't picked out this what looks like a very bright or dark channel, so it must be, maybe the water's flowing faster from right to left. This looks like it's some sort of shallow area. And so if you really want to collect a good variety, which is what you want to do to characterize this, you go into the shallows. When we're done, we can save the current training samples. You should do at least 3 sample areas. 4 or 5 is probably preferable. We'll look at another class. We'll go to ponded water. We just highlight ponded water, pick the same tool, and notice how fuzzy my scene is. So this isn't really what I want to be. I want to be nearest neighbor so I can see the individual pixels. So I got to click the right one here. See, now I know how close do I want to get to the boundary for this dark water. So I'm doing ponded water. And you want to be very careful about where you pick these boundaries. Because if you go into this, you're going to not have a very good training spectral character for that class. So we'll zoom out. And we'll just start collecting at least 3-4 training areas for each of these categories. I've completed my building my training samples: river water, ponded water, irrigated grass, dry grass, wetlands, suburbs, industry, and you can zoom in and see the extent of a nice broad look at the area. Over here is the more complicated. These are trees which have a lot of issues with shadows and everything. In the Lab 10 lab manual, the PDF, it talks quite a bit of one page about statistics and some resources on doing statistics, which is a very important component of the classification, building the training samples. What are the statistics between, what's the difference between industry and suburbs, and are they separated enough? So there's a whole array of tools in this software to do that. We won't do it in this elementary exercise. We want to make sure everything's saved. So these are, our diskettes are faded, so that means we've saved. But what's interesting is when you say close the training sample manager, you get this pop-up, and make sure that you saved everything to resume working, etc., etc. So we click yes, everything's here, and we saved it. Click the project. The project doesn't save the training samples, and so we can see when we open up our catalog that there's our training samples. So you can see I brought in my training sample polygons. I've lost the colors that I had in my initial training manager. Now we need to create a signature file based on these training samples so that we can run the supervised classification program, maximum likelihood. So go to geoprocessing, and you have to know to type in create signature, and it'll be our 8-banded image. Our sample data is there. The class name, I should have opened up the attribute table to check that. And then we just want to put it in the Lab 10 output. You can see I ran this once before to see how it was working. And we'll compute the matrices. And next we'll run the classification program. So we'll go back, and now we type in maximum likelihood. And again, it'll be our 8-banded. The signature file should show up, sig1. It's not apparent in my catalog yet, even though I've saved the project and refreshed. And I'll call this Lab 10 8 class map.tif. And we won't do any probability weighting. The default reject fraction 0 means that every cell is going to be classified. And there's our map. You can see it's color coded. It's at 8 classes. So let's look at our attribute table. There's our classes. So it looks pretty successful. Nice job. With the count, the number of pixels in each class, and the value that we typed in from our original classification legend that we built when we first started. So what I've discovered, I want to put the class name over here in the legend, and the way that I've done that, I'm sure there's other ways, is I go to unique values, and there I'm able to choose class name, and then I can color code these so that my river water is that same dark blue, my ponded water, and it says all these things, but it'll actually work. And I'll change the color scheme so you can see I've gone through and changed the color symbology, and now we're back to our original map and our original legend that we liked. And we want to save this, so we'll save it as a layer. Sharing, save as layer file in our, yeah, there it is. So going forward, we'll have this color combination, which is pretty pleasing. Now I would go through and run a majority filter on this most of the time, but we'll skip that for now, just so we can, it's different than the unsupervised. You can see all the detail and that salt and pepper look that some people like, other people don't. But what we're going to do is enhance the value. This is just a flat map, and it doesn't look very informative. But we can go over to the catalog and bring in our DEM, a hillshade DEM. So I've already got a layer on it. So we've added a hillshade DEM underneath, and then I'll go back and I'll highlight my map, and I'll go to appearance, and I'll start to fade it. And you can see it's much more informative. So over here in this area, that's our dry grass, because this image was acquired, as it says in the book and in the lab manual, in October after very long, hot summer and early fall. And this is the Naval Weapons Station, and those are actually big facilities. And you can see the runway. You start to see the facility infrastructure, the topography, and it's very helpful when you get over here to the southwest and you start to see where the trees are located and where the dry grass is located. So bringing in a DEM and other data will really help our land use, land cover map. Now, to make this map even more useful, we want to go to the insert a new layout, and we'll make it a horizontal map. There's a layout, and we want to go to map frame. It's always hard to remember, and add our map over here, let's say. And then we have all these things we can insert, and one of the things we want to insert, of course, is the legend. And you can go to work and make this larger and turn. We don't need this one turned on, we don't need that turned on, just those two, and work to make a pleasing map that you can, with a legend and a scale bar and all that, that you can output. And show also an example of that next. So using the layout tools, you can make a very informative presentation and documentation. Where did the DEM come from? Oh, it's illuminated from the northeast at 30 degrees above the horizon. It's a supervised classification. It has not been field checked. It is important to talk about what you did to QC this. We didn't do a formal accuracy assessment, which is a real drawback of this exercise. And so that should be documented. You should have metadata attached to this land cover map so that people going forward know its strength and its shortcomings. Now we want to use a different method compared to what we've done before. We're going to try using the field calculator to add area in square kilometers to this attribute table here. And so we can look at the Landsat's characteristic, and it's 30 by 30 meters each pixel in this data set. And so that means that it's 900 square meters per pixel. So we'll cancel this. What we want to do is add a field so that we can calculate area. Here's our field. We'll call this area. You're only allowed like 10 characters in the square kilometers. Float numeric. And we don't need so many decimal places to see. and then we have to save. I closed ArcGIS Pro, I rebooted the computer. Whatever I tried, I was unable to save this new field I'm trying to put together. And so I just gave up, and I'll close ArcGIS Pro. And I took the same file and I put it into desktop because I've already done this whole lab series for ArcGIS Desktop. And so here, open the attribute table. There it is, very simple. Add a field. We'll try the same thing. Area, square, kilometer. It'll be a float. And I'll do precision 8. Scale 2. There's my new field, so it successfully worked, it looks like. They want me to edit, I remember that, before you do field calculator. So here's my field calculator. And as we said before, each pixel is 900 square meters. What we want to do is use a Visual Basic script to write a formula and calculate the area of each of our categories. How much area is in here in square kilometers? So our formula would be count times 900. So each pixel gets multiplied by 900. Put that in a closed parentheses. Times 0.000001. That gets me from meters, which is what my pixels are in, to square kilometers. And it should work. And there it is. So our river water covers 26 square kilometers in this area, and our dry grass covers 40 square kilometers. So we have a very useful information. The field calculator tool looks like this in ArcGIS Pro. You can see we're going to use Python, which is pretty fun. And this is the count, same idea, times 900 times 0.00001. And it's a valid. And so you end up with this in the ArcGIS Pro. So the idea was, this is the last part of this exercise, to compare Python. Say you could do Python now to VBA and desktop. With that, we'll close the supervised classification lab exercise.